Hello, everyone. Thank you for attending our webinar on power management solutions. My name is Colin. I'm from the marketing department. Let me give you a little rundown of what we're going to be talking about today. Today, we're discussing ICP DAS USA's power management and monitoring solutions. What that means is that a power monitoring system allows users to be aware of real-time energy usage and expedite data collection and logging, reporting, and increase regulatory compliance. With a system of smart power meters, data loggers, power meter concentrators, and touchscreen PLCs, you can access power readings, historical data, and control functions locally and remotely. An effective power management system increases efficiency, regulatory compliance, and saves you money. If you have any questions at any time, please go ahead and enter them into the chat box. Like I said, I'm Colin from marketing. On the call today, I have Steve and Robert from engineering, and they will be able to answer any of your questions at the end of the presentation. So today we are discussing our power management and monitoring products, including the features of individual components. There we go. So this is our agenda for today. We're going to be starting with an introduction to our power monitoring and management solutions, the benefits of our smart power meters, a couple application examples, and then features and components of our individual products. So before we begin the webinar proper, here's a little background. ICP DAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP DAS USA, which is us, was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers. We work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, which means they are lead-free. We have our ISO 9001 certification, which ensures we meet product, statutory, and regulatory requirements. Okay, so energy meter technology. Our energy meters are compact, DIN rail mountable, powerful, and flexible for use with many different applications. Smart power meters give you access to real-time energy usage for single-phase and or three-phase power measurement. We have a wide selection of power meters that communicate over Modbus RTU, Modbus TCP, and CAN protocols. They support various input types, including RMS, kilowatts, kilowatt-hours, kilovolt amps, etc. They support current measurements of up to 1,000 amps. They can be used for power monitoring systems to measure power consumption and log data. So first we'll be talking about our Modbus RTU power meters. This is one of our more basic models, the PM3112. It's a power meter that supports 2 loops of single-phase power measurement. It communicates over, it can communicate with the control system over RS-485. It also has 2 power relay Form A outputs, so you can turn devices like lights or sirens on or off based on your energy measurements. It also supports power over Ethernet, so you can power it with an Ethernet switch, injector, or router. It is available in Modbus RTU and Modbus TCP versions and supports up to 240 amps. PM3112 supports operating temperatures between -10 to 70 degrees centigrade or 14 to 150 degrees Fahrenheit. They can be mounted on a control panel, or as you can see in the picture here, this one is a DIN rail mount case. So all of our power meters come standard with our clip-on current transformers, or CT. And CT is the instrument that measures AC current. And current transformers isolate measurement instruments from high voltage in the monitored circuits. A current transformer allows the production of a reduced current, which is accurately proportional to the current in the actual circuit. It can be connected to measurement devices like our power meters, and then data from the smart power meters is logged with other data logger devices. So another little more feature-rich power meter that I want to talk about is the PM3133, which is a 3-phase compact smart power meter that communicates over Modbus RTU. Again, this one is a DIN rail mountable. You can daisy chain Modbus RTU devices over RS-45. RS-45 networks support up to 255 devices in one network and support communication distance up to 4,000 feet. Again, the PM2133 has an industrial temperature range of -10 to 70 degrees Celsius. They come in the DIN rail or control panel mount, and again supports a wide array of power inputs. Okay, so one application for our smart power meters is in home automation. So information is gathered from sensors attached to data acquisition equipment. Lights can be turned on based on light levels or room occupancy. Energy is monitored and the information can be displayed on a touchscreen controller. The energy usage data can be shown as green or red if the energy usage levels is in the desired range or if it isn't. The information can be brought for viewing on a web page through our programmable device servers or serial to Ethernet gateways for RS-45 Modbus RTU-based devices. So power meter concentrators are essentially data loggers for use with our power meters. And the Cadillac of concentrators is the PMD 2201, which acts as a controller, concentrator, data logger, and monitoring station all in one. The PMD 2201 is a web-based smart power meter concentrator. It offers an easy-to-use web interface and features power data collection, logic control, power demand management, data logging, local display, and web display, and alarm and notification functions. PMD 2201 allows connections to smart power meters over RS-45 and allows you to monitor and control in real time. It allows you to monitor real-time power values and then record them on a local data logger file. PMD 2201 also provides data logger file auto sendback function together with PMC data server software or SCADA software. It allows the collection and analysis of power data through SCADA. It also has a bunch of built-in features. It doesn't require any extra software to program. It's configurable through a web browser. You can also access it remotely through a browser and control its functions from there, from a remote workstation. It also has built-in if-then-else logic, so that you can program and schedule functions from there. So basically, the PMD 2201, is everything you need to run a small power management system locally or remotely. It supports up to 24 of our Modbus power meters and 8 I/O modules, and you can use the built-in logic to take in data from the power meters and then have the I/O modules respond to that data. Again, this is perfect for use for home automation or industrial automation. It supports the same operating temperature range as the power meters. So it's quite the feature-rich little guy. Another power meter concentrator that I want to talk about is the PMC 5141. This is more of a standard data logger device that you would use with an external controller or SCADA system. So the PMC 5141 allows for logging and displaying of data from power meters. It has a real-time clock, so you can log the time and energy data. PMC 5141 comes with a 2 gigabyte micro SD card for data logging, and it supports up to a 16 gigabit card. They can log data from Modbus RTU devices and then can communicate back to SCADA over Modbus TCP. With power meter data loggers, you can predict power demands and manage and store power data. You can create different users that can log in through a web page to see the data, and different users can have different permission levels. It has 2 Ethernet ports and runs on a Windows CE operating system. And the PMC 5141 supports up to 16 Modbus RTU devices. And again, you can daisy chain these. You can daisy chain power meters over RS-45. You can log the data onto a micro SD card and store it in a CSV file. You can send the data logs back to a computer or server over FTP. You can get the data through SCADA using Modbus TCP. You can also monitor the data through a web browser from a PC or mobile device. PMC 5151 and 5141 can be used with other Modbus devices and can trigger outputs based on inputs. They can log data from various devices and then send the data back over a cellular network with a cellular modem. They support if-then-else logic rules and are configurable through a web page, just like the PMD. PMC 5151 comes with a 4 gig micro SD card and supports up to 24 devices. So another application example for these devices is in a solar monitoring system. So a photovoltaic system uses solar panels to convert energy from sunlight into electricity. Solar power monitoring systems consist of the solar panels, power inverters, current input sensors with AC and DC inputs, analog input modules, communication converters, and monitoring software. They provide detailed status information like kilowatt hours and temperature. The information can also be logged, so reports can be pulled up as needed by the users. PV systems can be hardwired, wireless, or internet-based, and provide power monitoring solar station information. So the solar panels are connected directly to the power inverters. Power inverters convert direct current into AC current. The power inverters are directly connected to current input sensors like our DN 843 series, which is a 3-channel current input sensor board with channel-to-channel isolation. The DN 843I-CT-1 can take in the amperage signal and converts it into a voltage signal. The current input sensor board is connected to an M7017 analog voltage-based input module, trying to communicate over a protocol like Modbus RTU. The M7017 module is connected to a communication protocol converter, the I7520, which converts RS-45 to RS-232. The I7520 is connected to a PC, which is running SCADA. And the screen on the PC shows detailed status information. It also features web publishing, so the PC is accessible over a web page from any computer. Zigbee wireless data acquisition modules and converters allow for a wireless Modbus RTU connection from the PC to the photovoltaic system. That's just an example of use with a solar monitoring system. Okay, we also have a couple of other local HMIs for displaying power data. Local HMIs can be used for displaying power data in your home and in buildings. Touchscreen PLCs we provide a compact, flexible, and can display in real-time power consumption data from AC lights and other electrical devices. You can easily turn devices on and off with the touchpad. It can fit in this device, the TPD 283, fits in a standard electrical wall mount, and is powered over Ethernet, so you don't need a separate power supply. We also provide free HMI Works ladder logic and C language programming and a GUI development for all of our HMIs. And this one easily integrates with our I/O modules. Another TPD, just really quickly, is the TPD 430H, which is another touchpad, but this one has a 4.3-inch screen, full color, high resolution, full color touchscreen, which is slightly bigger. This is a panel mount version. Communicates over RS-45 and USB. Again, supports a high range of operating temperatures for use in various situations. This one can be used with our power meters and lighting control modules for a home power management system. Okay, so that just about concludes our webinar. At this time, if anyone has any questions, feel free to ask them. Like I said, I do have some people from engineering here to answer any of your more technical questions. So if you have any questions, just go ahead and type them into the chat box. thought I saw a raised hand there, but okay, I guess not. So if there are no questions, we're going to go ahead and conclude the webinar. Thank you again for coming. Please feel free to take note of our contact information on the screen if you think of any questions. We have our office number there on the left and our toll-free number there on the right. Visit us online at icp-usa.com. Email us at sales@icp-usa. And of course, always feel free to follow us on social media. We have a Facebook, Twitter, YouTube, and LinkedIn. Oh, excuse me. I am going to be posting a recording of this presentation on YouTube later today or Monday. So, again, thank you everyone for coming. Have a great Friday.